Hello, today we're going to be continuing with 3.1. We're talking about properties of exponents. We have a few more examples we're going to work through just to make sure you can see how all the different properties of exponents work. So looking here at part D, we can see that we have a division, right? We got a term on the top being divided by another term on the bottom. And we just need to make sure that we can combine all of those variables together. So 3 things that you should look for. Make sure you look at the coefficients to see if those can be simplified. Make sure that you get all the variables together. And then last thing to look for is to make sure that you only have positive exponents in your answer. All right, so taking a look at this, let's look at this 8 divided by 2 first, right? So that's the first thing that we're going to look at there. And 8 divided by 2, that will reduce to be 4. All right, so now we're going to go to the next one. All right, we've got our x's. Do you see I have an x on the bottom and an x on the top? Now we could subtract those exponents, and then we'd have to take the reciprocal, kind of like we did on an earlier example. However, another way to look at this, and to maybe keep it straight in your head, is to think, where are there more x's? Well, there's more x's in the denominator. And then ask yourself, how many more x's are there in the denominator than in the numerator? And there's 2 more. And so that means that when we simplify this x to the 7th over x to the 9th, we're going to be left with just an x squared on the bottom. Or you could have done x to the 7 minus 9, but that's going to give you x to the negative 2 power, and then you would have to use that reciprocal rule and flip it downstairs. So you can see why it ends up there in the denominator. All right, let's look at the y's now. So taking a look at this, y to the 13th over y to the 4th. Again, we can think about, where are there more y's? Well, there's 13 on the top, 4 on the bottom, so more in the numerator. How many more are there in the numerator? Well, 13 minus 4 is 9, so y to the 9th goes in the numerator. All right, now let's take a look at the z's. So for the z's, we've got a z to the 5th on the top in the numerator and a z to the 8th in the denominator. So again, if I ask myself, where are there more z's? There's more on the bottom. How many more? Well, 8 minus 5 is 3, so z to the 3rd is in the denominator. All right, now we want to look and make sure that we don't have any exponents that are negative that we need to look at. And if we don't, we've got all of our variables together. We've simplified all we could there with the coefficients. So there is our answer, 4 times y to the 9th over x squared z to the 3rd. All right, so sometimes just working organized on this can really be helpful. All right, let's take a look at this next one. So now we've got negative exponents in both the numerator and the denominator. So I like to think of it as like this x to the negative 2, right? It is not happy upstairs. It wants to move downstairs. So I'm going to go ahead and just move this down here, right? And when I flip it from the top to the bottom, it's now going to be x to the 2nd power. So usually when I'm looking at things like this, I don't like to work with my negative exponents. I'd rather get them positive first and then work the problem from there. But you could work with them when they're negative and simplify it in a different way. There's more than one right way to work these problems. So if you thought about it a different way, just check to make sure that you get the same thing in the end there. All right, and then let's take a look at this next one. So this x to the negative 6 power is unhappy downstairs, so we're going to move it upstairs, and now it's going to be x to the 6th power. All right, and now we've got to get our x's together, right? We've got 6 on the top, 2 on the bottom, so that means we need to subtract those exponents, or again, think, where is there more of them? There's more on the top than on the bottom, so my x's are going to be on the top. 6 minus 2 is 4, so there are 4 remaining. So x to the 4th would be our simplified answer. All right, let's take a look at one more here. This time we have an exponent on the outside, and we need to make sure that we distribute fairly. We give that power of 3 to every single part that's inside. Right, so if I'm looking at this, I'm going to separate these by, like with little multiplication dots, so you can maybe see that there's 3 different things that we need to give that power of 3 to. Okay, so let's start by giving that power of 3 to the 2. Well, that's going to give us 2 to the 3rd power. Now let's give that power of 3 to our x squared term. So I'll write it down as x squared all cubed. And then I'll simplify it more in the next step. Yes, it can simplify further. All right, and then we give that power of 3 to the y term also. So I've got y to the 2nd power, all raised to the 3rd power. All right, and then on the bottom, we can't forget about that one. We also need to make sure that we give that z squared a power of 3. So we're going to give that power of 3 to this one also. So I've got z squared all raised to the 3rd power. All right, so now we got to simplify more. All right, so let's look at this and simplify this all. So 2 to the 3rd power is 2 times 2 times 2, which is going to give us 8. Then x to the 2nd power raised to the 3rd power. We're going to multiply those exponents together, because remember that we said back in our properties of exponents, a power raised to a power is going to be multiplication. So that's going to be x to the 6th power. And now we've got the y's, y to the 2nd all raised to the 3rd. Again, multiply those together. So that's going to give me y to the 6th power. And on the bottom, again, multiply those together to get z to the 6th power. All right, and there are no variables that we need to get together. There's nothing that we can do to simplify this 8 more, and there's no negative exponents. So I know this is all the way simplified, and that is my answer. Hopefully that was helpful for you in reviewing these properties of exponents.